Hello. Today, we're going to be learning algebra. Specifically, we're going to be learning about log.
So exponential equations are equations in which variable expressions occur as exponents. So before we start an example of exponential equations, let's explain the property of equality. So basically, if b is a positive number other than 1, then bx is equal to by if and only if x equals y. So basically, these exponents are equal to each other. So example 1 is solving exponential equations. So before we do this, we have to make the bases equal to each other. So we would make these bases both 3. And since this is a multiple, 3 times 3 is 3 squared. And 3 thirds. So basically we made the bases equal to each other so that we would make these exponents equal to each other. So we just bring these towards here. So based on this property of equality, these exponents are equal to each other. So we just bring them down and we ignore the base. So 2 times 2x is 4x. And if we distribute this, then it's 3x minus 3. We minus 3x on both sides. And x
Is equal to minus 3.
So I'm going to be teaching this example, which deals with exponentiating each side so you can get rid of the log. So as you can see, this looks like a normal example, and it would be if the log wasn't here. So I'm going to teach you guys how to get rid of the log. We just have to simply base the 5, since this is a 5 here. And obviously we have to remember to do the same to the other side. So this would become 5 to the power of 2. And then this would equal out to be just a 1, which makes it, disregardable. And so the final equation would just be this, and then we erase out the 1, and it's 3x minus 2 equals 25. And you can just solve it like a normal equation, putting the 2, adding 2 to both sides, which makes it 3x is 25 and 27, excuse me. And then you just divide it by 3, which makes the final answer of x equals 9. So just remember that you can base the number by the number of the log on both sides, and then you can solve it out like a normal equation. Thank you.
Hello, my name is Jazzy Jason, and today you'll be learning more about Now, as we finished with Minsu, we will be going to example dos. We're going to start off with taking logarithms each side. So basically what that means is just using log algebraically. So we have this equation, 5 to the power of x equals 12. And obviously in algebra, our goal is to leave the x alone. How are we going to do that? Well, what we're going to do is that we're going to put log 5 below, and by the rules of algebra, we're going to put another log 5 on the other side. Log 5 by 5 or log 3 by 3, any kind of situation like this, they take each other out, and that which equals 1, and that means x is going to be alone. And we're left with x log 5 to the power of 12. Now you're going to wonder, how are we going to get rid of this? Obviously, we're going to use a calculator. If your calculator is not updated, you're going to have to do it the classic way, which is just log 12 over log 5, and you're just going to input that into your calculator. Once you input that calculator, you're going to get 1.54. As I mentioned before, your calculator, if updated, you can just go on math and click on option A and just fill these numbers in. Now we're going to move on to logarithm equations. If bxy are positive, b cannot equal 1. Log 2x equals log 2, 7. X is going to equal 7. Obviously, they match and they're going to be equal. Going up to another follow-up question, it's going to be this equation. Like I mentioned before, you can get rid of it just by doing 6 and you'll equal 1. But if you have any common sense, you can just cross these out, which means 4x minus 8 equals x minus 4. Now we're going to solve this like any other normal algebra equation. Minus x on each side, which equals 3x, and then plus 8 on each side. So plus 8 is going to get rid of minus 8. Plus 8 is going to equal to 4. And then we have to leave the x alone. So we do 4 divided by 3. And this 4 over 3. And this is the question answer you're going to get.
Okay, since I'm independent Irene, I'll be switching things up a little and putting this on a clean sheet of paper. And this is my log. Now, if you look at this equation for the final example, you can see that it's like any other equation, but this will actually produce extraneous solutions. In this case, we have to check it later and see if they're correct.
Should be more than one. Now, we will start off by observing that these two parts of the equation have the same log. We will use the product property of logarithms and gather these logs, and then multiply these two. If we use distributive property, we'll find that it's x squared plus 12x. And now we have to get rid of the logs, because otherwise we can't proceed with making this equation and factoring it later. So by exponentiating both sides of the equation, we can get rid of the logs. So this means that we will set 4 as a base since it's log 4. And we will keep in mind that this will essentially make a 1 in the end. Now 4 cubed is 64. 4 to log of 4 is 1. And now we can solve it regularly. So you subtract 64 on both sides. Minus 64 equals 0. And now you can factor it. And when you factor this, it becomes x minus 4, x plus 16 equals 0. And then you set both of these to 0. This makes x equals negative 16 because you subtract 16 on both sides. This makes x equals 4, add 4. So you have 4 and x equals negative 16. But one of these may not be true. And putting them into the regular equation, we will find which one is true and which one isn't true. We'll start by x equals 4. Log 4 to 16 plus 1 equals 0, because log 4 is 1. And then this will make 2. And 3 equals 3. So yes, this is correct. And now we'll move on to x equals negative 16, see if that's true. Now, negative 16 plus 12 is negative 4. But if you look at this, this can't be solved, because there is no such thing as log 4 negative 4 number. So in this case, negative 16 is not a correct answer. So we'll eliminate this and find that this is the only answer available. So this is the answer to the equation.